Gold. For thousands of years, it has been the ultimate symbol of wealth, power, and perfection.
But before it shines in a vault, it begins here, buried deep within billions of tons of solid rock. From violent extraction to delicate precision, the journey of gold is a masterpiece of industrial engineering.
Today, we take you inside the world's largest gold processing facility. Witness the complete process, from dusty ore to luxury bullion.
The process begins in the pit. Geologists must first identify the ore body, often hiding less than 5 grams of gold per ton of earth.
Once the target is locked, massive drill rigs bore holes up to 20 meters deep into the bedrock.
These holes aren't for mining, they are for destruction. Each is packed with ammonium nitrate explosives.
The blast must be calculated perfectly, enough to shatter the rock, but controlled enough to keep the pit walls stable. With the rock fractured, the heavy lifters move in. These hydraulic excavators are among the most powerful machines on Earth.
They lead a fleet of ultra-class haul trucks. A single vehicle here can carry 400 tons of payload.
Loading takes just 3 passes. The operator sits 2 stories in the air, piloting this mechanical beast.
The journey out of the pit is slow and treacherous. The trucks burn massive amounts of diesel to haul the heavy ore to the surface.
Their destination is the primary crusher, the first step in liberating the microscopic gold particles trapped inside the stone. In seconds, 400 tons of rock vanish into the throat of the plant. The gyratory crusher acts like a giant pestle and mortar, reducing boulders to manageable rocks.
This creates a continuous river of ore, feeding the processing plant 24 hours a day.
But these rocks are still just rocks. The gold is invisible to the naked eye. To find it, we must grind this mountain into dust.
From the stockpile, the ore travels into the heart of the operation, the grinding circuit. This is where brute force meets fluid dynamics.
The SAG mill is a rotating beast, driven by motors with thousands of horsepower. Inside, steel balls and the rocks themselves act as hammers. As the drum turns, the contents cascade, shattering the ore upon impact.
Water is added to the mix, transforming the dry rock into a liquid pulp known as slurry. The slurry flows into the secondary ball mill. Here, millions of smaller steel balls grind the particles down to the thickness of a human hair.
Any rock that isn't ground fine enough is rejected and sent back to start the cycle again.
Hydrocyclones use centrifugal force to sort the material. Heavy, gold-bearing solids are spun to the outside.
For chemical processing, we use gravity. Because gold is 19 times heavier than water, high-speed centrifuges can snatch the free gold directly from the stream.
This creates a super concentrate, the first glimpse of real value.
On the shaking tables, the density difference is undeniable. For the first time, the gold reveals itself, a ribbon of yellow fire against the black sand.
This high-grade dust bypasses the chemical plant and heads straight for the furnace. But for the microscopic gold still hidden,
the remaining slurry is pumped into massive thickener tanks, removing excess water to prepare for the chemical extraction.
the mechanical work is done. Now, we must rely on chemistry to dissolve the gold atom by atom. The goal is total liberation. We need to expose the microscopic gold particles locked inside the silicate matrix.
We enter the most chemically complex phase, the carbon and leach circuit. These massive reactors are
a precisely calculated solution of sodium cyanide is introduced. While dangerous, it is the only chemical capable of dissolving gold efficiently on this scale.
The reaction is magical. Solid metal transforms into a liquid gold cyanide complex, detaching itself from the waste rock.
Oxygen is pumped in to accelerate the reaction. The slurry is kept in constant motion for up to 48 hours. But the gold is now floating in an ocean of mud. To catch it, we use activated carbon, derived from roasted coconut shells.
This carbon is a molecular sponge. It absorbs the dissolved gold from the solution, concentrating it onto its surface.
It's a countercurrent system. The carbon moves upstream, getting richer and richer in gold as it advances toward the first tank.
Once fully loaded, the carbon carries up to 10,000 grams of gold per ton. It is harvested and washed, leaving the waste rock behind. The loaded carbon is transferred to the elution columns. Here, high pressure and 140-degree heat reverse the process.
The gold is stripped from the carbon, creating a super-concentrated, high-grade solution called the pregnant electrolyte.
The waste rock, or tailings, is neutralized and pumped to a secure storage facility, monitored 24/7 for environmental safety.
Sustainability is key. Up to 90% of the process water is recycled and sent back to the start of the circuit.
Meanwhile, our pregnant gold solution heads to the most secure location on the property, the gold room.
Beyond this door, cameras are everywhere. No one enters alone. This is where the liquid finally becomes solid metal. In the electrowinning circuit, electricity becomes the new catalyst. These stainless steel cells are the final trap for the gold.
We immerse cathodes made of fine steel wool into the pregnant solution. This creates a massive surface area for the gold to cling to.
A powerful electric current is passed through the system. The gold ions in the liquid are magnetically drawn to the steel wool.
Over several hours, the gold plates out of the liquid, coating the steel wool in a thick, dark layer. To the untrained eye, it looks like rust.
This creates the loaded cathode. It doesn't look like luxury yet, but this dark sludge is over 80% pure gold.
High-pressure water strips the gold precipitate from the steel wool. The sludge falls to the bottom, ready for collection. To remove the water, the slurry is pumped through a filter press. It squeezes the mixture with tons of force, trapping the solid gold solids.
The result is filter cake. It feels like wet clay, but this tray alone is worth millions of dollars.
But it's still wet. We load the cake into a calcination oven to dry it out and oxidize any remaining impurities. Moisture evaporates, and base metals oxidize. The material is now bone dry and ready for the fire.
Before smelting, we add a secret recipe of flux, borax, and silica. These chemicals will help the gold separate from the impurities during the melt.
The flux acts as a cleaning agent. It will bind to the waste material, making it float, while the heavy gold sinks.
The mixture is loaded into a high-grade graphite crucible, capable of withstanding temperatures that would melt steel.
Everything is prepared. The chemistry ends here. Now, we rely on pure heat.
The induction furnace roars to life. Instead of fire, it uses high-frequency electromagnetic fields to generate heat directly inside the metal. The induction furnace roars to life. Instead of fire, it uses high-frequency electromagnetic fields to generate heat directly inside the metal.
Within minutes, the solid powder surrenders to the physics of heat. At 1,064 degrees Celsius, gold turns to liquid.
The flux does its job. Impurities bond with the borax to create a layer of slag that floats on top, leaving a pool of pure metal below.
A pour requires human precision. Operators don specialized aluminized suits to deflect the radiant heat that could blister skin from meters away.
There is no room for error. A spill here isn't just a mess. It's a loss of hundreds of thousands of dollars. The molten mix creates a cascade of fire. We are pouring doré bars, a semi-pure alloy of gold and silver. As the molds fill, the lighter slag cools on top, forming a crust that protects the precious metal beneath.
The bars are left to cool. The blinding light fades, hiding the treasure under a layer of waste.
The bars are left to cool. The blinding light fades, hiding the treasure under a layer of waste.
Once solid, the bars are knocked out. They don't look like jewelry yet. They are covered in a brittle shell of glass-like slag.
Once solid, the bars are knocked out. They don't look like jewelry yet. They are covered in a brittle shell of glass-like slag.
This is the most satisfying moment for the crew. Shattering the slag reveals the solid core of the doré bar.
These are doré bars. They contain about 80 to 90% gold. Valuable, but not yet perfect. Each bar is weighed and logged, but to sell on the international market, we need 99.99% purity.
We need to refine it one last time.
Each bar is weighed and logged. But to sell on the international market, we need 99.99% purity. We need to refine it one last time.
A sample is drilled from the core to verify the exact purity before the final refining process. A sample is drilled from the core to verify the exact purity before the final refining process. The hard labor of mining is over. Now, the science of perfection begins. The bars head to the electrolytic refinery. The hard labor of mining is over. Now, the science of perfection begins. The bars head to the electrolytic refinery. The doré bars arrive at the refinery. Here, the environment shifts from industrial brute force to achieve the legendary 4 nines purity, the gold must be disassembled atom by atom. They are cast into anodes, thick plates designed to hang in a chemical bath. They act as the positive terminal in the electrolytic process.
We use the Wohl-Will process. The tanks are filled with a potent mixture of hydrochloric acid and gold chloride.
The impure anode is lowered alongside a cathode of pure gold. When the current flows, the anode begins to dissolve.
The impurities, silver, copper, and platinum, separate. Silver forms a sludge at the bottom, while the gold travels through the acid.
This is the moment of purification. Only pure gold atoms can deposit onto the cathode.
When removed, the cathodes are covered in rough gold crystals. This is the purest form of the metal industrial. The crystals are washed and scraped off. We now have gold sand, a wet, heavy pile of incredible value. Once dried, this material is known as casting grain. It is the raw material for every luxury watch, ring, and bullion bar on Earth. It flows like water but hits with the weight of lead. It is perfectly clean, perfectly pure.
Before the final melt, a sample is sent to the assay lab. If it is even 0.01% off, the entire batch is rejected.
To create a delivery bar, we don't use rough ore. We use the pure casting grain. It is weighed to the exact gram before entering the final furnace.
The metal must be poured at precisely 1100 degrees Celsius. Too cold and it ripples. Too hot and it shrinks.
The mold is coated in carbon soot. This ancient trick acts as a lubricant, ensuring the gold doesn't stick to the iron and comes out with a mirror finish.
The pour is a test of steady hands. A single splash or bubble ruins the bar, forcing the team to melt it down and start over. A final pass with the torch pops any microscopic air bubbles, ensuring the surface is flawlessly smooth.
As it cools, the gold crystallizes. This is the bloom.
The bar is quenched instantly to lock in the crystal structure and cool it for handling.
It emerges cool to the touch. A solid kilogram of 99.99% pure gold.
Now, science verifies the art. An X-ray fluorescence scanner bombards the surface to confirm the chemical composition to the molecular level.
Ultrasonic waves peer deep inside the core. They ensure there are no air pockets or, worse thing, hidden bars of tungsten disguised as gold. Weight is currency. We always pour slightly over. A customer will accept 2 extra grams, but never 1 gram less.
The press applies tons of force to permanently mark the bar. This stamp is the refinery's guarantee, recognized by banks worldwide.
Finally, a unique serial number is engraved. This digital passport.
Flawless, physically dense, chemically pure, and aesthetically perfect. It is ready for the vault.
Gold doesn't rust, but it is soft. To protect the mirror finish from scratches during transport, each bar is vacuum sealed in tamper-evident polymer. The assay certificate acts as the bar's birth certificate. Without this paper, the bar is just metal. With it, whether destined for a central bank vault or a private collector's safe, the packaging must reflect the value of the contents. This room holds the GDP of a small nation. The density of value here is mind-bending.
While the gold sleeps in the vault, the cycle at the mine never truly stops.
Maintenance is critical. The abrasive dust destroys machinery, so the fleet is washed down daily to prevent corrosion. The rock takes its toll. The steel liners inside the mills are chewed up by the ore and must be replaced by maintenance crews working through the night. Responsible mining means closing the loop. Water quality is tested daily to ensure the surrounding environment remains untouched. In the refinery, even the dirt is valuable. The floors are vacuumed and the mops are incinerated to recover every last speck of gold dust. Leaving the factory is harder than entering. Every employee is scanned. A single flake of gold in a pocket triggers the alarm. Under the cover of darkness, the transport team arrives. These vehicles are bulletproof fortresses on wheels.
The payload is loaded. Tonight's shipment is worth $50 million.
Sealed, signed, and secured. The gold is ready to leave the factory gates.
The convoy disappears into the night. This shipment is destined for the bullion markets of London, Zurich, and New York. Gold is a global currency. Within 24 hours, this metal will cross oceans, moving from the remote mine to the center of the financial world.
Some bars will end up here, in the reserves of a central bank. They will sit in silence for decades, anchoring the stability of national currencies.
Others will take a more personal path, melted down by artisans to become symbols of love, commitment, and heritage.
It is a journey of extreme transformation. We turned a mountain of gray rock into a single kilogram of perfection. This metal is indestructible. The gold in this bar could have been mined by Romans, melted by Incas, and from the deep earth to the highest standard of purity. This is the story of gold.
Thank you for watching. Subscribe to Gentech Insights to see what we build, mine, and manufacture next.